This is one of a series of videos produced by the Further Mathematics Support Programme for A-Level Mathematics Revision. In this video I'm looking at the AQA M3 specification, and this is question 7 from the June 2010 paper. The question tells us that a ball is projected up a smooth plane which is inclined at an angle of 35 degrees above the horizontal, and the ball is projected with a velocity of 20 meters per second at an angle of 30 degrees to the plane. In other words, it is what's shown in the diagram. It says the motion of the ball is in a vertical plane, and the ball strikes the inclined plane again at point A. We're asked to find the components of the velocity of the ball parallel and perpendicular to the plane as it strikes the plane at A. In other words, when it arrives at its destination or at its first bounce. After that, we're told that the ball bounces and rebounds, and there's a coefficient of restitution that we need to take into account between the ball and the plane. And we're simply asked then to show that the ball strikes the plane at a point that is lower down than A. Well, the first part then is quite standard. We're going to take our x and y axes parallel to the plane and perpendicular to the plane like this. So probably the first thing we need to do is consider the acceleration due to gravity g, and to realize that it will have components given by g cos 35. 35 is the angle plane, and that's in there, that's 35 degrees, so that the component perpendicular to the plane will be g cosine 35 degrees, and the down the plane it will be g sine 35 degrees. So the two components of the acceleration due to gravity. So if we first of all take the resolving perpendicular to the plane, looking in the y direction, and use s equals ut plus 1/2 a t squared. The actual s component, because it's landing along these axes here, it's like landing on the plane again, then the value of s in the y direction is 0, so we get that 0 is equal to u. Well, u perpendicular plane is the component opposite the 30-degree angle of our speed 20 meters per second. So opposite gives us a sine, so we get 20 sine 30 degrees multiplied by t, and then minus 1/2. It would be g, and the component we want is g cosine 35 degrees, so minus 1/2 g cosine 35 degrees multiplied by t squared. And if you calculate that, then there's a little bit of simplification we do. First of all, sine 30 is 1/2, so this is 10t, and then 1/2 g is 9.8. There's not a great deal though, then t squared. So we can factorize out of that t. So t equals 0, obviously that's when it started, or t is equal to 9.8 cosine 35 degrees. And sorry, I beg your pardon, 10 over that. And that turns out to be 2.49 seconds. So the time of flight is 2.49 seconds. Now we can use our parallel to the plane and perpendicular to the plane using v equals u plus at to get the velocity that it's going to hit the plane in the u and the y direction. So first of all, along the plane in the x direction, so let's call that Vx. That will be equal to the initial v, so u, which is 20 cosine 30 degrees, and then minus the acceleration. That direction is g sine 35 degrees, And if we calculate that, it becomes, you can see it's equal to 3.32. In the y direction, Vy, similar 20 this time. Obviously the components are going to change, so it's sine 30 degrees, and then minus g cosine 35 degrees. I'm sorry, I missed out the time t in there, and time t 2.49 seconds, and that turns out to be negative 9.99. The marking for this part of the question then was an M1 and A1 mark for finding the time, and then M1, A1, there's actually an A1 follow through there, and M1, A1 follow through for working out those two components. The next part of the question asks us to decide whether the ball, having bounced, strikes the plane at a lower point than A. In fact, we have to show that. Now, one way to do this is to work out the angle at which the rebound takes place. And we know that the angle of the plane is 35 degrees. If we then calculate the angle of the rebound, then the total angle will be the 35 plus the angle of the rebound to the plane. Now, if that total angle there is greater than 90 degrees, the ball is going to, in effect, bounce backwards. If it's less than 90 degrees, it's going to go forward. So what we need to show is that this angle here, plus the 35 degrees, is greater than 90. Well, to calculate that, we can take the components on rebound. The x component is not going to change, so we've got that Vx is equal to 3.32 from the first part of the question. There's a coefficient 4/5 of restitution, coefficient restitution of 4/5, so that will change the excuse me, with the y component will now be equal to 4/5 multiplied by the 9.99, or two significant figures 10. So that gives us a value of 8. Therefore, the angle of this will be tan to the minus 1 of the 8 divided by 3.32. So this is the angle to the plane. And this is equal to 67.5 degrees. We can now say, therefore, that the angle to the horizontal is equal to the 35 plus 67.5 degrees, which clearly is greater than 90 degrees. And therefore, it strikes at a point lower than A. There were 6 marks to doing this part of the question. There's a B1 mark, it's actually again a follow-through mark for calculating the rebound velocities, the components. M1, A1 for calculating the angle 67.5 degrees. And then M1, A1 for showing that it's greater than 90, and then finally an explanation mark. So a total there of 6 marks for that part of the question. Well, that's the end of that question. There are other questions and information that you can find at www.furthermaths.org.uk.